Hello and welcome to our webinar today. My name is Tony Andrews. I'm an independent technology journalist. Our topic for the day is envisioning the future of transportation. And we're going to do that in a very concrete way, specifically looking at autonomous trains. Now, for some people, that is an area of huge excitement, and for others, some trepidation. And I'd like to take us all on a journey where we explore how some people get from one end to the other. And specifically, I'm looking at a project called Sensors for Rail, which had all sorts of partners involved, and they're going to speak to each of them in their turn. Some had design expertise, and some had technical expertise that they brought to this project. But we're trying to figure out, how did visualization play a role in helping people develop a sense of comfort, security, and maybe even excitement about the future of transportation. Here's the agenda of what we're going to be doing over the next few minutes, but let's get started. I have with me here Chris from DK&A, who's going to give us some context of what is going to happen in the rest of the webinar. So, Chris, we have a number of partners on board. Give us a sense of who is on the boat with us.
Hello. Yes, so we have multiple partners who are involved in the project. So definitely Deutsche Bahn, Siemens, IBO, Bosch, and Here Technologies, also our partner, Wake One. We are together in this project.
And these different partners have different roles, some design, some more technical. Can you give us a sense of what different roles they played?
Yes, of course. So each partner was responsible for other things. Deutsche Bahn was, of course, responsible for the coordination of the whole project and initiative. Also, a lot of software and building software. Bosch and Siemens, also IBO, were responsible for the sensors, lidars, radars, and cameras, who are together combined, giving the multiplied source of the positions for the perception and localization. And Here Technologies was delivering the digital HD maps, which were crucial to localize the train with the precise manner.
And what about DK&A? How are you involved?
So we are experts in building the digital products, and here this challenge was a little bit different. So we were assigned together with Wake One to create a visualization about what is happening in the project, exactly what the train sees. Sometimes in the project, during the product development cycle, you need to explain to your customers or stakeholders what is happening inside the project to convince them to the project that they will feel good with that. And since this is really innovative project, we are delivering showcase demo visualization that people will be able to see live on ITS first in Hamburg in the train live.
Visualization is the keyword for the rest of this webinar. Can you tell us how visualization is connected to empathy and why that's so important to us?
Yes, of course. So I think that mainly we as human beings, we are using visuals to have a perception of the world and what is happening around us. So empathy and seeing what is happening in the complex context of technology is bringing trust, especially to something which is really innovative, like semi-autonomous trains in the future. So we wanted to bring human touch and user experience to this complex technology and explain how it's working to the broader audience, that people will be able to see what the really train sees. And I think that this is the core of what we did and why we used empathy as a tool to do that.
Well, let's go ahead and see for ourselves. There's a lot to learn, and let's chat to our first partner.
Thank you.
So we're kicking things off with our first guest, with Sebastian from Deutsche Bahn, and he's going to be telling us about sensors for rail. Sensors for rail, Sebastian, what is it about and what are some of its biggest benefits?
Yeah, so the Sensors for Rail project is part of a bigger program, which is called Digital Rail Germany. And it's focusing on three aspects. We have prepared an overview image, and you see highlighted the three aspects we're focusing on. So at first, we equipped a train with manifold sensors, so radars, cameras, and lidars. And this way, we are gathering large amounts of data of the environment of the train. We are processing the data on the train and deriving significant information from that, which is key to subsequent functions. Furthermore, we are making use of a further but virtual sensor, which is the HD map, which can be regarded as a priori information and gives extensive foresight. And by combining the online perception, so what the train is actually seeing, with the digital map data, we gain another function, which is the sensor-based localization. So by comparing extracted landmarks from the perception with landmarks that are part of the digital map, we can precisely localize ourselves. And based on this precise localization, we can introduce significant improvements with regards to efficiency, capacity to the railway network. And an enabler for this is the connectivity. So our train is all the time connected to the cloud. And from the train, we are uploading data to the cloud side, but as well downloading data. So the map data on the train is steadily prefetched from the cloud side, and additional information from the train is uploaded. This is a huge benefit. So we will see later on a short video, but all this information we are gathering can be provided to a control center and is there of huge benefit for the railway network of the future. And this brings really big benefits.
And what would you say triggered the creation of the visualization application? And I think you have a snippet to show us to help us visualize it ourselves.
So what you see is what we are presenting at the ITS World Congress, giving you a first glimpse at it. So we have prepared a few highlight features that we are showing. You see them here activated simultaneously. So we are presenting landmark-based localization. We show track detection, pedestrian detection, and also assessment. So the criticality of pedestrians is assessed and visualized. We are also showing highly precise localization, which is based on multiple paths, and the paths are perception based. So we can precisely localize without the need of additional infrastructure. So just by means of our sensors, and also the free space detection. So very, very key features for further functions that we would like to introduce to the to digitization of the railway network. And visualization is very important, was during the project very, very important to us, because it helped us significantly with putting together the puzzle pieces. So we are a huge project with multiple partners, many software components, which have been at the beginning developed independently. And then when you are starting to integrate these components, even when your interfaces match, you identify glitches, that some puzzle pieces are not fitting exactly. You need to adjust. And for identifying such glitches and making this very, very complex work perfectly, you need the right tools, and one of these tools is a proper visualization, which is bringing all this information together and allows you to fix such problems. And this was very, very important to us. It helped a lot. And on the other hand, what we intend to do is also to present or to give the public insights. So we are presenting our results at the ITS World Congress. And therefore, it's also very important to have a well understandable and tangible visualization for the public. So in the end, we have a win-win situation at this place. So we are both, tackling the engineering needs for system integration, and we are tackling the presentation needs for informing the public how the digitization of the railway system is progressing, what we are working on, and how we intend to shape it.
Yeah, let's stick with those presentation needs. I think one of the biggest is for people to just have a sense of trust in these kinds of projects. Would you say this kind of technology helps to build trust?
I think so. Yeah, it's when you take as a passenger a look at these visualizations and maybe at adverse weather conditions. And it's maybe imagine a foggy situation and the radar, and we are doing sensor data fusion, but the radar sensor would be a main driver under such adverse weather conditions. And you can still recognize persons far, far away. Yeah, although the human side is already at its limits. It's very impressive. And I think presenting technology in such a way is very convincing and builds lots of trust. Yeah. So I would say that visualization and showing results, making them very transparent as we are doing, is helping a lot. Yeah.
And Deutsche Bahn has definitely been on its own journey in terms of this visualization. Would you encourage other companies to use visualizations in such complex projects?
Yes, 100% yes. So it helped us a lot with system integration, and as I mentioned, putting all these many puzzle pieces together, and this independently developed software. And we were able to identify many glitches and to fix them in a proper manner. And so the benefit for the project was huge to put all these. We had individual visualizations, but you want to optimize the interplay of the overall system, and then you need something that combines all the data, And therefore, I would say yes, significantly. And on the other hand, it's a win-win, because we are using the same visualization that we used for the engineering part as well to present the data to the public, to give them insights. And this is the presentation we'll be showing at the ITS World Congress. So a clear win-win, and we can recommend it, of course, for such big projects.
All right, a lot of lessons to be learned, and we look forward to hearing about that from other partners in the rest of the webinar. Thank you so much, Sebastian, for your time. And now we have our first technical partner. We have Siemens. Joining us is Sasha, who's going to be telling us about his contribution to the team. Sasha, tell us about how Siemens contributed to the project, please.
So Siemens contributed with two main tasks within the project. One is the localization unit that's consolidating all the information about the position into one final position for the train front. And the second thing is we contributed with our experience for the integration of the system. So basically making it running and making it work like it shall be working and shall be running. So we can deliver the experience we see and we have now within the visualization at the end of the project. That's a really important step.
Yeah, if we could hone in on that visualization aspect, at what point did you realize that this was really important for the success of your project in getting engaging visualizations?
It was pretty clear from the beginning that a good visualization is important for the people, because you really need to see and need to show what is be done in the system. That's not easy for all the parts of the system. That's important for all the perception work, for all the perception detections that is happening, to see what is happening there, how is it happening. But it's also important for the localization part, because it's something you usually do not see, and that's not visualized anywhere, because it's just happening in the background of the safety system of the train. And therefore, it's a really important part to see what is happening there with the inputs, what is the end result of the localization, to give the people a feeling how the result is working, how the system is working.
And did you see any particular improvements in terms of your collaboration stemming from using Showcase?
Yeah, it helped us very much, and it helped us a lot in finding out some problems at the end, because we have seen that there are difficulties with the system behaving on the base of different times of the information that are coming up. And therefore, it helped us really to optimize the system at the end, to overlay all the different positions that are coming with different timings and on different time frames. And that helped us a lot in finding some small mistakes that usually would take weeks of data analysis, because you only have the recorded data, but you do not have everything simultaneously, and that helped us a lot in finding some difficulties we had there.
And how did Showcase contribute to the experience in terms of, people's safety and comfort, or at least how they perceive it?
I think it's important for people to know and to see what is happening here on the technical side, because especially with all the perception perception that's happening here and the visualization, it's important to give the people a feeling what they can imagine, how the system is working. Because if they don't have any kind of visualizations, they can imagine lots of stuff, but this is helping imagining the right information, imagining the right behavior of the system, and so they can get a better feeling on what is happening and what tasks are taken over from the system by the system.
And this field has been going for a good number of years. What are some of the recent improvements in technology that have made your work and also the work of others in the field easier?
A big improvement in technology is really the range of the sensors and the detection with the sensors, because when we're talking about the rail business, we talk about braking distances of about 1,000 meters for a casual train or more, and therefore you really need to have these range to detect objects or persons and so on, because that's really important. We cannot avoid anything that's on the rail. We can only brake, and with such distance, it's important to have long-range cameras and long-range view. And when you're, for example, talking about automotive and cars, there you have sensors with about 200 meters range, which is more than sufficient for any braking distance. And that's a really big challenge in the train business. And therefore, it was a really big step forward with the project. We have ranges of more than 500 meter. That's the first step, and that's a really big improvement, because that was not possible a couple of years ago.
And is that a reason for you to be particularly optimistic about the future of transportation?
Yeah, that's making me really optimistic, because from the technology side, it's important to make this affordable, because we know from lots of experiences years before that technology-wise this is already possible, but we are talking about really, really expensive technologies there, and therefore this project is a big step forwards to make this affordable for the train business. And therefore, I'm quite optimistic that we can achieve the needed results within a couple of years, especially with the ranges of the sensors. I'm pretty optimistic that this will make a big step forwards within the next years as well.
And do you think visualization will help the general public get on board more quickly in terms of how they perceive things?
Yes, it is necessary to perceive and to transport the needed messages to the public, because they need to be aware, and they made aware about what is needed, and what the challenges with the technology are. And also it is important that we're delivering the right messages in terms of data protection, for example. That it's important that we are computing information, but we are not storing personal information, for example. That's important, therefore, that we have abstract visualizations that are supporting these messages, that nobody needs to fear any kind of data protection or privacy issues.
All right, I think we'll leave it there. Thank you so much, Sasha, for that insight into the project. Thank you so much.
Thank you very much for being here and for the invite.
Next on the list, we have Peter from Bosch. Peter, could you tell us what your contribution was to this project?
Our contribution was the so-called perception part. This means all the sensors you need to get the surrounding, to understand the surrounding, to identify objects. This includes cameras, so video cameras, infrared cameras, also radar sensors, and also the computing unit and the functionality behind this to compute all the data and to bring it together. In the end, to find out what your surrounding is, where objects are, where the tracks for the train is, and so on.
Okay. And at which stage of the initiative did you realize that there was this need for visualization?
At a very early stage, with all project partners, we defined that we need a visualization for the ITS Congress. This was clear from the beginning, but this was sort of put aside because we had to develop the system at first. So we concentrated on the functionality, on bringing everything together, on having a first prototype and improving this. During this development, we found out it's hard to communicate with others to explain how good things are and where we may have issues. And at this point, and that was, say, half through the project, we realized we really need to show the data and not just have single data points and graphs and lists. And there we saw we need a visualization.
And what kinds of improvements or benefits did you see from the visualization process?
What we saw is it's very good to have a better understanding on how the different systems work together. We are several project partners. The systems are complex, and it's a hard task to really understand how things interact. And the best way for a human to get a feeling here is to have a visualization. It's also that we have a lot of video data because we, for the functionality, need the raw data. And it's tough to get through all this data, and the visualization helps to see the main points, to identify some kind of effect that you normally would not see without any visualization. So it's actually for us as humans to understand all the data.
And what sense of, how do you think the showcase contributed to the average person's idea of safety or comfort?
Actually, the showcase is put on top of the system. So the final system will not have any visualization. It will simply work to help the train do its job. But during development, or to show others like project partners, customers, or the public what is really happening, this visualization is essential because you can't dive into these boxes and see what they are doing. So for this part, for development and showing what the project is about, the visualization is essential.
Okay. And how important do you think the visualization is in terms of collaboration with other partners?
I think it's very important because when you're working on the day-to-day basis, everybody is working with his own tools, deep into his functionality. Of course, everybody is talking about the interface, how things work together, but to have a common basis for discussion and analysis of the system and the progress we make, it's good to have this visualization for everybody to get into the talk about improvements, about performance, about what we want to achieve. Because before we have the visualization, maybe it's not clear to everybody what the project is about and what we want to achieve and what we can do. Because it is so complex and everybody is sort of caught in his own subsystem and component or function.
Yeah. And last question for you, Peter. What are you most excited about in this field of visualization as a tool for making things more accessible and engaging for audiences?
What I'm most excited about is there are many things that are interesting, but I think it really, with this visualization, you see what the technology does, how it works, and what it sees. Otherwise, you would not really be able to grasp this. And this is quite impressive. You see how fast things are computed. You see how different computing units work together. You see the performance of different sensors, how different sensors can be combined. And without a visualization, you could not really understand this.
All right. Well, thank you so much for your time. We appreciate it.
You're welcome.
Next up, we have Raymond here from IBO. Raymond, could you give us a little sense of your contribution, or specifically IBO's contribution to the project?
Yes, so we are first of all delivering LiDAR sensors. So actually our new Aerial solid-state LiDARs there, and actually 6 sensors for each system for both sides of the train, for example. And additionally, we provide a set of functions for the using those LiDAR data. So first is for sure publishing or delivering point cloud data to all the partners to see that they can use for their development and their functions. Second, we detect landmarks based on the point cloud data, like pillars and walls that we use for providing actually the third function there. And this is the precise localization. So because we can localize or we can use the landmarks to match to a HD map there and localize ourselves within the map. And the fourth function actually is then to provide occupancy detection, so that we can detect obstacles around the tracks or close to the tracks, on the railway system. And those functions then contribute to the development of the functions for Bosch is developing, and also DB, in terms of to define use cases there and applications for the future railway system.
And at what stage of the initiative did you visualizing the data?
For sure, we need to visualize the data when we want to see what is happening there, how the data look like in the railway system. So when we are going to use the LiDARs in the automotive sector, then we quite know how the data look like. In railway systems, they look different. We need to know how they look like there. And for sure, we need to see the outcome of the function. So we are developing algorithms there. And for sure, we need to see what is the outcome of the algorithms, what the algorithms are doing to calculate. And for sure, we need then that to show this to stakeholders, to tell them what are the functions there, what is the future developing there, and last but not least, to have the ITS visitors, for example, in this case, that can see what is the perception system doing here, what is the algorithms are doing here, what is the function doing here, and and therefore the visualization here is very important to see what is actually doing there, what functions providing what. Yeah.
Raymond, you mentioned LiDAR previously. Could you tell us a little bit more about how LiDAR relates to positioning a train in relation to other objects like obstacles or landmarks?
Yeah. Each solid-state LiDAR from us has built in a 2-dimensional laser array there. And each laser shoots out a light there. And so we can measure the distance of an obstacle there, so measuring the time of flight actually, and including the intensity information, how reflective an object is. So, and we can sum up all those data to a 3-dimensional point cloud there, including the intensity information, and can use this data for doing some algorithms, some data processing algorithms there. And so that means we can do some kind of clustering algorithm, some extraction of features there. And so we have information then where the features are in the world, so in this 3-dimensional space. And so we can then use this information to classify them as landmarks and then to match those with the predefined or pre-recorded HD map. Yeah.
I think you brought a video along. Could you tell us a little bit about the video?
Yeah, sure. I would like to show how the point cloud actually look like, so you can have an impression about the data actually itself. So we are driving here past the station Tiefstack here, and we see all the pillars and poles there on the station, even some pedestrians there, as well as bushes and trees close to the track, which is also important for the surveillance of the environment of the track. And as well here, for example, one part of the frame structures of bridges. And next, another part is where you can see also the outcome of how the voxels would look like. So you see here in red those voxels which we use for the function. And there you can nicely see also similar structures on the station, the pillars, as well as the bridge here from the station there. Yeah.
I think what this video shows is sort of the necessity of visualizing data in a way that people can understand and engage with. How do you think that relates to people's sense of safety or comfort with autonomous trains?
Yeah, so for sure, when people are entering autonomous trains or cars, then they like to be safe in it. Yeah, and normally when you enter those cars or trains, they do not see anything what the vehicle is doing. So it's good to make the visitors or the passengers familiar with how the data look like, what are the sensors detecting there, and that they are detecting something. So, and this could help for sure to make the passengers comfortable when they see, okay, the sensors are detecting all these obstacles here, the passengers and the walls and the trees there. And so the passengers are then somehow comfortable, maybe, okay, when the sensors can see those obstacles, then the trains can also react on them and to make this driving more safe.
All right. Well, thank you so much, Raymond. That really helped me to get a better insight into how trains are positioned and also how they visualize, how things are visualized for the trains and also potentially for the general public. Thank you so much.
You're welcome.
And here we are with our final technical partner. I'm speaking to Michael from Here Now. Michael, could you tell us about map making in this part of the process, specifically in how map making was crucial to the success of the project?
Yeah, Here technology started map making many years ago. But we also started developing an HD map for highly automated driving vehicles only a couple of years ago. And in the context of this program, we were selected to provide an HD map for rail, which was actually at the start of the program a completely new opportunity to implement our existing experience in map making into the railway industry. So that was really an exciting new opportunity for us that we can contribute with highly precise maps also in the context of railway. And therefore, this was really a great opportunity.
And can you tell us about the importance of visualization in general? How important was it for your collaboration with the partners?
The visualization, especially of components that are usually immaterial, untouchable, basically, is absolutely crucial in order to communicate the progress of the program and the progress of the individual development components, right? So if people cannot look at the things that are there, it's impossible to understand where are we, where is the problem, what are the next steps, and where is the potential gap towards the joint goal. And here specifically for the maps, it is so relevant because almost every component of this solution is in some way dependent on the availability of map components. And that means every project partner would have to understand what the map actually provides. So therefore, visualization is absolutely critical.
And did you see any improvements in your work or collaboration coming from building or using this kind of showcase?
I mean, the big benefit for us is that we learn to understand how HD maps can actually contribute in the railway context. As mentioned before, that was completely new for us at the beginning of the program, and we learned that it can provide significant benefit to the overall solution. Actually, you can think about it as a fundamental paradigm change. So usually in the railway industry, a lot relies on hardware built into the tracks, which is actually very costly, high maintenance, and requires a lot of resources. And now towards a software-driven, augmented reality and artificial intelligence-based approach based on high-definition maps. So it's a really significant change, and we're absolutely proud to be able to participate there.
And how would you say the showcase contributed to or contributes to the experience in terms of safety or comfort?
I mean, the overall goal is to create a system that is even more reliable as today's systems, which is actually a pretty high challenge, right? I mean, especially in railway, the significance of system reliability, system security are extremely high because there's lots of life on stake. Therefore, this is the ultimate goal, and location technology plays a significant role there. However, there's still a little bit a way to go because we're in the early stages of this development. Actually just completed phase 1 of the Sensor for Rail program, phase 1 out of 3. So there's quite a bit of development still ahead of us.
Yeah, and a lot of exciting developments at that. We're going to leave it at that. Thank you so much, Michael, from here. We appreciate your time.
Thank you too. It was a pleasure.
And right here we are looking at some of the design aspects of this entire process. And to do that, we're speaking to Kari from Wake One and Florian from DK&A. DK&A, we'll start with you, Florian. Could you give us a sense of the role of design in the context of innovation?
Well, I think in the context of innovation, design and designers, they take on many roles. In this particular case, I think our designers took on a role of negotiators, empathetic negotiators or diplomats. When designers join a innovation process, we usually find a disconnect between what people know and understand and what the product is trying to achieve. And this is a gap that we are trying to bridge by communicating to our customers' audience in a way that's meaningful to them. And I think that was the job that we were doing in this case.
Yeah, Kari, speaking of the audiences, maybe you can jump in here. Who is the audience of this visualization, and why is it important that we understand them, if we get just the absolute basics?
I think for any visualization, it's really important to understand who is the audience, because as Florian said, it's about empathy and understanding how they view the world. And in this specific project, we're talking about technology that's gonna be available, and it's gonna affect the lives of everybody. So we're talking about self-driving trains. And I think in this type of case, it's a complex technology. So making it visual in a way that people understand it, it's really important so that we can adapt that.
Can you give me a little bit more about that, Kari? What's the process involved? Like, how do you turn so much data into a visualization?
Yeah, it always begins with learning. So we go to the customer, we try to understand like what are the basic building blocks of the technology, how does it work, and how does the actual business work, so that we can make the core message with the customer. After that, we gather the data. And in this case, we had a lot of data. So we have map data, we have track data, we have multiple real-time data sources. And not all of this data is available when we start the project. So it's an iterative thing that happens. We extract what we have and then create this initial story, iterate with the customer, and then as we get these real-time data sources online, then it all comes up. Comes together as this magnificent visual experience.
Magnificent visual experience sounds very comforting. And on the other end of that spectrum is fear. Florian, could you tell us a little bit about how visualizations are used to address fears that people who, when they think about the future of transportation, it's not all magnificent, and there may be some fears. Can you tell us about how visualization addresses that?
Well, I can tell you how design, I think, tries to address this, and this we have now mentioned this a few times. A good designer, I think, for me is first and foremost the person that can bring empathy to the table. We sometimes, actually quite often, don't necessarily share the concerns of the audience directly, but we need to be able to take their viewpoint and understand where they're coming from, maybe like a psychoanalyst. And then we can address that by providing information that alleviates these fears. Fear, in the end, is just incomplete knowledge, to quote Agatha Christie. And we are able to address that by providing information that our audience needs to understand what's going on. And we're providing that in a way that's simple enough that they can follow along, but not oversimplified so that they think we're trying to hide something or skew the reality. And I think that's the job here. That's the job we're doing.
I think that's a really interesting word you just used there, empathy. It's one that I wouldn't initially expect in this kind of setting. Would you say that's one of the most important aspects in terms of addressing fears and design and visualization?
Yeah, I think, that goes way beyond design, but I think that's definitely, that's the most important skill that I think we need to be able to employ here, for sure.
Kari, you'd like to jump in there?
Yeah, because I think what is important in creating this visualization is especially in this case, as we have all of this data, it is important not to overload the people. As we have multiple data sources, we have LiDARs, radars, maps, all these voxels. So they are all new to this audience. So what we do is we have to introduce them basically one by one and design the experience in a way that the core message comes through, so that not everything is just put together and so that people get overwhelmed.
Yeah, and Kari, you from Wake One, this is not your first project like this. Can you tell us about some of your previous work in the field that has enriched or influenced the project?
Yeah, we've done this for many years now, and especially with the global technology companies. So the environment is usually the same as in this project. So we have a lot of stakeholders. We are supporting the marketing and sales efforts. We are using the cutting-edge technologies, and that's something that we get from the experience that we had is that we understood from the start that this is a challenging project. So we have onboard live animation. We have the same data used for online stuff. We have the same data used for ITS fares. So understanding like how to use each technology and make it come together as a smooth performance. I think that's something that we have learned along the years.
Even though Wake One has been doing this for a while, Florian, the entire field is still at the beginning of a quite a long journey. Can you tell us about how you think the future of visualizations will pan out, or at least will progress as in terms of developing technology projects?
Yeah, I think that, so we coming from a slightly different angle than Wake One, because DK&A is more of a product company, digital product company. So we are trying to bring sort of a tooling aspect to this when we do this for our customers. So we try to enable them to use this for other purposes than just explaining what they're doing in a sort of a more like a marketing context. And I think that's where the space is heading in general. We see our customers getting a lot of benefit from using these demos or these visualizations for ongoing product development and R&D sometimes, validation with their customers. They sometimes move completely over to the demo development and then only later on extract some valuable information that they've gathered or insights, and then put that back into the product development efforts that they have ongoing. And then I think a really important aspect that we often forget is the internal communication that they have going on. In many cases, these projects are new and disruptive and maybe questioned. And it is important to generate internal buy-in and get funding and all these important things that we like to ignore. And putting something into your hand that you can use or click or touch or experience in some way that can be understood in minutes time often goes a really long way for them to do what they need to do.
Kari, how's technology changing this process? You mentioned some of your previous experience, but what's happened in the last few years and also even recently to bring this process further along?
Yeah, I think what we have seen is that the world of visualization is changing into something more dynamic, real-time, immersive, more natural. So this underlying real-time 3D technology, it's disrupting these old ways of doing things. So for example, we can have a digital photo shoot, photorealistic images that normal people won't notice that the actual product does not exist. It's only a design. So, and this project would not have been possible a couple of years ago, or it would have been prohibitively expensive to make. So I think this real-time 3D technology, it will enable, as Florian said, even better internal communication also. So as we are doing it iteratively, so it's not something that's done at the end, but it's a part of the whole process, like in this project also. So it enables better communication between all the stakeholders.
As you in your respective companies have been developing projects like this, what makes you excited about this entire process? Have you seen people engaging with the visualizations and actually having aha moments? Can you tell me a little bit about your personal connection to this?
I think these projects is very easy to get excited about because you're always talking about the future. You're talking about something that is either still in development or is just being thought of, and it's usually completely new. The challenge of bringing that down to a level that we can talk about it with our audiences is something really difficult often and exciting. But generally, I think it's exciting to get about it, to talk about it, because we're talking about the future. We're talking about something that is yet to be completely shaped, that's going to often impact the way we live our lives and interact with each other. So I think that's probably the most important aspect for us as designers.
Yeah, Kari, for you, what really gets your eyes lit up about this kind of project?
I really love to work in the intersection of these customer technologies and visualization technologies, so that we can. I love the moment when I see that we finished the experience, the product, and I see how these people understand what this is about. Because that's what we do. We take the complex customer technology and make it something that people can actually understand. And we utilize the latest and greatest technologies like virtual reality or this photorealistic 3D to make it happen. So I think that's for me the thing that makes me tick.
That's great, and it definitely comes across. Thank you to both of you for your time. We really look forward to finding out more about this in the future.
Thanks.
Thank you.
There you have it. We've heard from all sorts of fascinating partners about their participation in the project, from design to localization. Now it's your turn. We'd like to hear from you. We have a question and answer session going on right now. Feel free to enter your questions into the chat. Our partners are standing by to give you their answers. And so I am going to get going with the first set of questions. The first one we have is for Sebastian at Deutsche Bahn. Sebastian, what is going to happen in the next phase of the project after the showcase at ITS is one of the questions we have. I think you're muted. Sebastian, it seems that we have a problem on your face. I'm going to go on to the next person, and maybe we'll come back to Sebastian. I'll move on to Florian. Florian and Kari specifically. So Jutta Jörlich says that we keep talking about empathy, but would like a concrete example of what this means in a technical environment. Maybe Florian, you'd like to take that one.
Yeah, sure. I think a big part of what we do is to try and take a viewpoint, try to understand the mental model of whoever we're talking to. And that's often quite different from what we do. Depending on the situation, depending on the stress level, depending on their previous experience on their day or in their lives, people will perceive very concrete data points differently than us and than others. They might perceive things like speed differently or complexity and so forth. And that's what we're trying to solve.
Maybe then for you, Kari, another question we had on this topic is, how would you translate empathy into technology solutions?
Yeah, as we are working with this complex technology, both on the production side and what we are trying to explain, I think the human part is very important. So the designers we have, they are like that's the human component. So as Florian said, we try to understand like what the audience really feels and experiences when they see it. And other thing is that we use the correct technology. Like for example, I'm really excited about the future as we can use the 360 technology, virtual reality technology, which is gonna enable even like better and more empathetic solutions as people get immersed in those.
Okay. We have another question for Sasha at Siemens. Sasha, this question is from JF Grossen, and they ask, are we building these visualizations with live data?
Yes, absolutely. We are using all data live from the system, how it's calculated for the showcase and for the visualization. There's nothing pre-recorded or anything. It's live data like it's currently processed within the system. That's why at some points there might be some glitches available, but that's how the system currently works. And everything is not scripted. It's just scripted in case of what is shown when, but everything you see there is from the real environment scene and calculated.
Thanks a lot. The next question is for Bosch, Peter. So I don't have a name for this question, so I'll just phrase it generally. So how are these sensors used for localizing the path? And then there's an example here. Say a train is going at 150 miles per hour, and the sensor can see at most 300 meters. How will it stop if there's a pedestrian or an object on the track? So there we have a kind of case study for you.
Okay, I'll try to answer this as good as possible. The question of the braking distance and the range of the sensors was a crucial question from the beginning. Luckily, this train is driving at 100 kilometers per hour. The braking distance is not too large, but still we need sensors for roughly 500 meters to detect if objects are in the way. And this is one part of the research and development we did here to find out with which sensor we can detect at what range specific objects. And this is also what is being visualized. We're concentrating on persons at trains for the beginning, and the target, of course, is when detecting that something is on the track in the way, the train needs to be able to react or to help give the right reaction. For this, we have sensors with a very large range, specific ones that were implemented and tested here for the very far distance, especially video cameras. And by the way, this system, as its research and development, is not acting on the brakes of the train. So we still have a train driver in this train that has full control and responsibility.
All right, thank you. We have some clarification. That question was from Mohammed Abbasi. So thank you, Mohammed, for that question. The next one we have is for Raymond at IBO. And this is Paravash Pajutan. And the question is this new system integrated with other rail systems?
The system now we have defined in this complexity, all these kind of sensors. Actually, this is the first time which we apply in the rail system. For sure, you will find some sensors in other railway systems, like in trams or in underground trains, like the code wheel devices, or even radar. Maybe you will find some in some applications or projects or even research projects. But for this complexity and this function with all the technology we developed in the first time for automotive, we now developed or we now integrated for the rail. It's actually the first time for us in this in this field. And we're excited also to make more out of it, to have more projects in, and to come up maybe in products afterwards.
All right. Next up, we have a question for Michael at here, and this is from Francesca Adriana Balisi. Can this technology be integrated to road-based public transport? And if yes, how so? And if not, can you suggest technologies that could be incorporated with passenger intermodal terminals?
Thank you very much, Francesca, for the question. That's really a good point. The fascinating thing about this program is that we at HERE Technologies, we already developed our so-called HD live map a couple of years ago with a primary goal to support highly automated driving use cases in vehicles that includes passenger vehicles, can also be used in public transport vehicles, any kind of vehicle that actually uses standard roads. And you had asked me at the time, like 3-5 years ago, if similar things could actually be applied also to railway transportation. I would have said, I don't know, I'm not sure. But to be able to discover actually that the same kind of technology, which is very similar actually, also from a sensor perspective, from a way we localize based on landmarks, is now used for railway localization, is really very exciting. And therefore, clear answer is yes. It's very similar, and we basically use the same technology in vehicles today in order to power highly automated driving.
All right, thank you so much. We're going to give a quick try to see if we can get Sebastian from Deutsche Bahn back. Sebastian, do you want to give me just a quick sign of your audio?
I hope the audio
okay,
works.
yes, I can hear you. That's
Excellent.
great. So that's perfect. I'll just rephrase the question for you again. What is going to happen in the next phase of the project after the showcase at ITS?
So we are planning an extensive data acquisition phase after the ITS. So the train will be around 1 year. So for season testing, and we'll acquire lots and lots of data and use this data for improving, for example, our machine learning networks to tweak the functions. And so it's the phase after the ITS is very, very valuable to us. Yeah.
And what are your general expectations, just to stay with you, Sebastian, what are your general expectations towards the audience reception of this visualization at ITS?
We hope that the general perception will be of the project will be very good. I mean, we are giving very early insights and how we plan to digitize the railway network, what we are working on, and this will be a very long process, of course, that will take many years. But we are aiming for technology readiness by 2030, and so these are the first results, and we will work really hard on this for the next years.
I'm just going to have one more question for you, Sebastian. And one we have in the chat is, will you be using this tool beyond ITS? And if so, where and how?
By this tool, what do you mean by this tool, or what is meant by that? So if by tool is meant the overall setup, so the train with the sensors and the software, the clear answer is yes, we will use as many results as possible. Of course, we'll have to tweak certain things. After the ITS, we are already planning updates of the software. So this is a continuous process, but this is the foundation for us, and it's therefore very, very valuable.
All right. So those are all the questions I've received from our listeners. Thank you to all of you for sending us in your questions. And I think our partners have given us added depth through their responses. I'm just checking if another one has come in for, I think we already had Florian. So I'm going to thank everybody for being on board at this point, to all of our partners. So that includes Deutsche Bahn, DK&A, Wake One, Siemens, Bosch, IBO. And here, it's been a real pleasure learning from all of you and for giving your insights. Thank you. Thank you so much. And we look forward to hearing about this in the future.
Thank you very much.
Thanks, everyone.
Thank you.
Thank you for the guests.
Thank you very much for the time.
Thank you very much. Bye-bye.